Welcome everyone. The question that is shown on the screen that is came in the CBSE 2025 pages question paper set number 2. Write Coulomb's law in vector form. That is very easy. Obviously, if you say that is here is a point charge that is Q1 and here is another one point charge that is Q2. Okay, and they are separated by a distance. Okay, they are separated by a distance. And obviously one thing I want to say here that these two charges are the point charge, okay, not the charges just like this. Okay, if we have given some charge into it, you have to consider this thing as a point, otherwise you cannot apply the Coulomb's law. You have to assume any kind of charge distribution, whether it is have a particular shape and size, you have to consider it as a point, then you can use the Coulomb's law. So there are two charges, one is Q1 and another one is Q2, and these two are point charges and they are separated by a distance r, say. Okay, but when we try to write it down that Coulomb's law in vector form, at that time we will see that what is the force acting on 2, that is the Q2 charge, due to 1. Okay, so force acting on the charge 2 due to the charge 1, force acting on the charge Q2 due to the charge Q1. So I am just writing down force acting on Q2 due to the charge Q1. It may be attractive, it may be repulsive. Okay, it may be repulsive, but depending on that the force vector will change. Okay, just like if I say both are positive, or both are negative, that means they are of same nature, then what will happen? Then Q2 will feel repelled, and that is in that direction, obviously, due to this presence of the charge 1. So what will happen? Now if I say this is the R21 vector, okay, this is the position coordinate of the charge 2 with respect to the charge 1. Okay, with respect to the charge 1, what is R1? Position of Q2 with respect to Q1. Clear? So from here, obviously, if I try to write it down, that is, it will be F21 vector, and that will be Q1 multiplied by Q2. We can say 4 pi epsilon naught, which is a Coulomb's constant in space, in free space or air. R21, if I say this is the vector magnitude, then cube, then R21. What is the reason behind this? Because it is Q1 Q2 by R square. So I am writing down here is a cube and here R21 vector, or we can write it down, it is Q1, it is Q2 divided by 4 pi epsilon naught R21 vector magnitude square R21 cap. So that is the F21 vector. Clear? So Coulomb's law in vector form is written, or if you want to find it out what is F12, for the time being, if I write what is F12, so I think you know what is F12, force acting on Q1 due to charge Q2, then it will be Q1 Q2 4 pi epsilon naught R12 vector cube R12 vector, or Q1 Q2 divided by 4 pi epsilon naught R12 vector square R12 cap. Okay, and obviously depending on the nature of the charges, if you say one is positive and one is negative, then the directions will change, the magnitude remains the same, and depending on that, obviously the vector expressions, obviously depending on our considerations, it will change. Okay, so here next question is 2 point charges Q1 that is 10 microcoulomb and Q2 that is 20 microcoulomb. Q1 is placed at origin 0, 0 and 20 microcoulomb is placed at 3 cm cross 3 cm, 4 cm in the xy plane. Find the magnitude of the force exerted on Q2 by Q1 and the angle that the force makes with the axis that we need to find it out here. Okay, so magnitude we have to find it out, and the directions also we have to find it out. So for that purpose, so if I just draw, this is the x-axis and this is the y-axis, and at 0, 0 10 microcoulomb charge is placed. Okay, here is the 10 microcoulomb charge, 10 microcoulomb, that charge is placed at 0, 0, and another one, that is the 20 microcoulomb charge, that is placed at 3 meter, 4 meter, x equal to 3, x equal to 3 meter, x equal to 3 meter, and y equal to 4 meter, let us say here. So that is at 3 meter, 4 meter, this 20 microcoulomb charge is placed. Okay, let us say this is my Q1 and let us say this is my Q2. So this is the direction and both the charges are positive here. So direction of the force, obviously it is repulsive. Now what is asked there? The magnitude of the force acting on Q2 by Q1. Okay, so you can say we have to find it of the force on Q2, and Q2 will want to repel in that direction. Okay, in that direction. So force acting on Q2 by Q1, force acting on Q2 by Q1. So force acting on Q2 by Q1, see the notation, force acting on Q2 by Q1, F21. Okay, so what is the F21? What is the magnitude of F21 if I write down? That will be Q1 into Q2 R21. What is the value of this vector? Obviously, if I write it down, what is R21 vector here? What is R21 vector which is necessary? That is basically 3i cap plus of 4j cap. Okay, if you want to find it out, what is the magnitude of this R21 vector? That's a root over of 3 square plus of 4 square meter. So that will become root over of 9 plus of 16 meter. So that's root over of 25 meter. So 5 meter. Very simply. So I am just putting this value here. Q1, Q2, 4 pi epsilon naught R21 square. Okay, R21 square. So obviously the value of the Q1 is 10 microcoulomb. So 10 into 10 to the power minus 6. Q2 is 20 microcoulomb. So 20 into 10 to the power minus 6. Okay, 4 pi epsilon naught. So that can be written as 9 into 10 to the power 9. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. R21 square is 5. Okay, so 5, it is 2. 2 into 2 is 40. 40 into 10 to the power minus 6 into minus 6 is minus 12, multiplied by 9 multiplied by 10 to the power 9. So if it will be calculated, 40 into 9 is 360, multiplied by 10 to the power minus 12 plus 9. So that will become 360, multiplied by 10 to the power minus 3 Newton, or you can say this is my 0.36 Newton. Okay, 0.36 Newton. Now what is the direction? So direction is obviously in a direction of increasing R. Okay, so we can say this is nothing but R21 cap. R21 cap. Okay, so we can find it out like this way, that is R21 vector divided by magnitude of R21 divided by magnitude of R21. What is R21? R21 vector is 3 I cap, so it is 3 by 5 I cap plus of 4 by 5 j cap. I think these calculations you can do. This way we can write it down. So in that terms, so the force F21 in vector rotation, we can write it down, that is 0.36, that is the magnitude, multiplied by 3 by 5 I cap plus of 4 by 5 j cap. This way we can write it down, or sometimes we can write it down in this way, that is the direction in terms of angle. If 3 by 5 is the x and 4 by 5 is the y, then we can say what is the value of the tan theta. Then tan theta is y by x, so not 3, it is 4 divided by 3. Okay, so from here it is tan inverse, obviously theta equal tan inverse 4 by 3, that is equal to theta. Okay, so we can write it down here also, that is the F21 vector, so that is 0.36 comma 0.36 Newton comma tan inverse 4 by 3. If you know the specific angle, that is actually tan inverse 53 degree, angle is 53 degree, so we can write it down, then it is 0.36 Newton, 0.36 Newton comma 53 degree. So several ways you can write it down, this answer 53 degree angle with the x axis. This angle we are talking about, this is the 53 degree and this is the 4 meter. Okay, this is the 4 meter. Okay, so magnitude is 0.36, angle is 53 degree, or you can write it down as a 3 by 5 I cap plus 4 by 5 j cap, as you wish. Thank you all of you.